Welcome to this pre-50 class on chemistry. And today's topic we have oxidation and reduction. Sections in this topic: Section 1, Oxidation. Section 2, Reduction. Section 3, Oxidation number and balancing of redox equation. Section 3 and Section 4 are merged together, so the final section is Test for oxidizing and reducing agents. Listed below here are the specific objectives of this lecture. By the end of this lecture, candidates should be able to identify the various forms of expressing oxidation and reduction, classify chemical reaction in terms of oxidation or reaction, balance redox equation, deduce the oxidation number of chemical species and compute the number of electron transfer in redox reaction, and so on. Introduction. Oxidation is one of the most common reactions in the chemical world. Oxidation always occurs simultaneously with reduction. Whenever this happens, a word, redox reaction, is used. Redox reaction is a word given to a reaction where you have oxidation and reduction. So you have red, denoting reduction, then oxygen. Red is for reduction, ox is for oxygen. When you combine the two, you have redox. One can see that it is always a difficult task to handle oxidation differently from reduction. But for a near perfect understanding of the topic, oxidation is treated separately from reduction. Because these two reactions occur simultaneously, when you have two reacting species, one will be undergoing oxidation and the other will be undergoing reduction. So they occur simultaneously. You can't really separate the two. That is why you have a redox reaction, that is handling the two chemical reactions in one, oxidation and reduction. So, but for ease of understanding, in this section we'll be dealing with oxidation. Then in the next section, we'll be looking at reduction and the various definitions. Starting with oxidation. Oxidation has 4 definitions. The first definition: oxidation is a reaction in which oxygen is added. Consider the following common reactions below. You have heating of copper metal in air, where you have 2Cu plus O2 to give you 2CuO. Copper has been oxidized to copper oxide. Burning of sulfur in air. You have S plus O2 to give you SO2, sulfur 4 oxide. It also means that sulfur has been oxidized to sulfur 4 oxide. Exposing nitrogen 2 to the air, 2NO plus O2 will give you 2NO2. And in this case, NO was oxidized to NO2. Second definition of oxidation. Since there mustn't be oxygen in the definition of oxidation, let us look at the next definition of oxidation. As we have here, oxidation is a reaction in which hydrogen is removed. Consider the following reactions. Zn, that's zinc, plus 2HCl will give you ZnCl2 plus H2. CH4 plus Cl2 to give you CH3Cl plus HCl. CH4 was oxidized to CH3Cl because it lost one of its hydrogen, having just 3 here. Or CH4 plus 4Cl2 to give you Cl4 plus 4HCl. In this case, it lost 3 of its hydrogen to just have 1 left. Third definition of oxidation is a reaction in which electron is lost. Oxidation is a reaction in which electron is lost. You have 2Fe to give you 2Fe3 plus 6 electrons. Note that the above equation can be rewritten as 2Fe minus 6 electrons to give you 2Fe2+, meaning that ion has been oxidized. Zn to give you Zn2+ plus 2e, or if you rewrite it as Zn minus 2e to give you Zn2+. Also, zinc has been oxidized to Zn2+. Fourth definition of oxidation. Oxidation is a reaction in which there is an increase in the oxidation number of an element. The parameters to consider when dealing with oxidation reactions is you have to find out which of the elements is oxidized, which of them is reduced, and then you also have precise use of oxidation states, that's oxidation numbers. Oxidation is a reaction in which there is increase in the oxidation state. Increase in the oxidation state. For example, Na plus Cl2 will give you 2NaCl. Oxidation number, oxidation state, you have Na at this state is the oxidation number is 0, but here the oxidation number is +1. Chlorine at this state, the oxidation number is 0, but in this compound, the oxidation number of chlorine is -1. So there is an increase in oxidation states for sodium. Sodium was oxidized, but because its oxidation state increased from, or oxidation number increased from 0 to 1. So sodium was oxidized in this reaction. Another example, 2FeCl2 plus Cl2 to give you 2FeCl3. Fe ion in this compound has an oxidation number of +2, but in this compound, iron 3 chloride, the oxidation number is +3. So you see that iron was oxidized from +2 to +3. While chlorine, on the other hand, moved from -2 in this state to -3 in this state, meaning that it lost an electron. So this is oxidation for iron Fe and reduction for chlorine Cl. In all example, Na moved from 0 to +1, while Fe moved from +2 to +3. The fourth definition is the most accepted definition of oxidation. And you remember that the fourth definition says that oxidation is a reaction in which there is an increase in the oxidation number of an element. Increase. Oxidizing agent. It is a substance, element or compound that causes oxidation. It is always the electron acceptor. So in this case, the oxidizing agent will be reduced because it is this oxidizing agent that will accept the electron that will be released from the compound that is undergoing oxidation. So the oxidizing agent causes oxidation. Examples of oxidizing agents are oxygen, hydrogen peroxide, acidified potassium tetroxymanganate 7, manganese 4 oxide, acidified potassium hepta, oxochromate 6, chlorine, conc triazonitrate 5 acid, hot conc tetrazosulfate 6 acid, silver salt, and any ion low in the reactivity series. These are all oxidizing agents, and in the two examples we dealt with, that of sodium and chlorine and iron 2 chloride and chlorine, in both cases chlorine was the oxidizing agent. Recap. Oxidation is either a reaction in which oxygen is added to a substance, or hydrogen is removed from a substance, or a process of electron loss, or an increase in the oxidation number of atom. And this is the most accepted definition of oxidation. So if I were you and I'm asked to define oxidation, I will start with this definition and then others follow. Oxidizing agent is always the electron acceptor. With this, we come to the end of this section.